In this module, we're going to look at data model and data structure within CAGen using Studio Developer. At the outset, I'd like to point out that this module is not a training course on data modeling, entity relationship modeling, data normalization, or data analysis techniques. We're primarily going to be looking at how you model those in the CAGen model. So if you need any further information on how you would go about designing your entity relationship model, you'll need to consult elsewhere for that. Within CAGen, we have the ability to define entity types and also something called a subject area, which is a grouping of entity types, which allows you to break down or categorize large complex data models into subparts called subject areas. So within a subject area, I can create child subject areas. So within the root subject area of training, which is the name of our model, I'm going to create a subject area called infrastructure. And then within infrastructure, I'm going to create my entity types. And the example I'm going to use is we want to have a user table so that we can store details about the users who are logging on and also the history of their logon. So I'm going to create a new entity type, and the name I'm going to give it is user, and I'm going to specify some occurrence maximum, minimum, maximum, and average number of occurrences, and then I'm going to specify the technical design name, which will become the table name, as t_user, assuming that's my standards. So then when I press apply, the entity type is created, which allows me to create attributes. And what I'm going to do is just take the logon work user ID that we already created, and I'm just going to copy that by dragging that in here, and that creates me a user ID attribute within my user table. And then I'm going to add in a couple of additional attributes: first name and last name. So there are my three attributes, and the final thing I need to do for the entity type is to create an identifier. So I'm going to call that iUser. It's going to be the primary identifier, and I'll drag the user ID attribute in there, and so the entity type is identified by the user ID. So there's my first entity type, and I'm going to create a second entity type, which will be, I'll just add it in, will be my logon history. So there's my entity type, and an attribute I want is the logon timestamp. So that's going to be a timestamp attribute. And then I need to know which user the logon history is for, and the way we do that is by creating a relationship. And I could create it from either end. So if from the user, I can create a relationship to the logon history. So each user sometimes has one or more logon history. That's the relationship from this end. And then from the other end, each logon history is always for one user. And then I'll specify the delete rules. So when I delete a user, I want to delete the logon history, and when I delete a logon history, I want to disassociate the user. So there's my relationship. So that's the logical data model created. And then within CAGen, the logical data model is kept separate from the physical data model, which is called the data structure. And we use the data structure editor to define that. Before we go into the data structure editor, I'll just show you the technical design defaults, because they are used when you're designing your data structure. So if I double click on that, we see the different types of database management systems supported by CAGen, and in my example I'm going to be using Oracle, and so we can see the name defaults like the database name and various other properties, like I want the referential integrity enforcement to be done through CAGen rather than through the database, and maybe I want my table space treated as a default DBMS table space, various other properties for the tables and the indexes. So that's where those are defined as the defaults. And then within the data structure, I can then implement my unimplemented entity types. So I'll pick both of those and press implement. And then there are no databases yet because it's a new model. So I'll create a default database, and then we're given an error. Entity type does not have an identifier. So this is just a double check. Every entity type must have an identifier to be implemented. So I can just come in here and realize I've forgotten the identifier for the entity type. So I'll create that. And that will be the timestamp and the user as the identifier. So now I can pick my entity types again, and this time that's okay. So I can go ahead and implement those entity types. So that's created my database, which I can expand to my table spaces, which expand to the tables, and they expand to the columns and the indexes. In this case we have the table space here, and within each of the objects you can specialize the objects for the particular database you're interested in. So I can specialize for the table space for Oracle and provide some additional values specific to Oracle. For example, I may want to auto size the table space based on the tables and columns that are within it. And similarly, I can specialize that one as well. And rather than specializing them individually, I can pick a top level object like either a table space or the entire database and use a synchronize function, which will go ahead and specialize all of those objects for my chosen database, which is Oracle. The final thing that is worthwhile doing every time you make a change to the data model is to run something called the RI process, and this synchronizes the referential integrity rules defined at the database level with any changes you may have made to the RI rules in the logical data model for the relationships. So there's my data structure defined, my database, table spaces, tables, columns, and indexes. You'll notice here that the foreign key for because of the relationship, the user ID identifier of the user table has become a foreign key in the logon history table, and we have a default naming standard for foreign keys. One of the nice things about Studio Developer is you can customize that foreign key naming standard with something called a model preference. So there are naming rules for indexes, link tables, foreign keys, attributes. You specify rules, and then when the logical data model is transformed into the physical data model, rather than having to use a default set of rules that come with the product, you can specify your own naming rules so that the names suggested meet your standards, and you don't have to go in and then immediately rename them to conform to your own database naming standards. So that's within the model preferences. So now that I've defined the data model and the data structure, I can go ahead and generate the data definition language. And so I'm going to just check my options, and I'm generating for Windows Oracle, which is correct. So I'm going to pick all of those objects and generate the DDL, install it, and just in case I've already defined them, I'll include a drop as well, and press process. So that generates the DDL and then runs the build tool, which defines the objects in the database. So if I was to just bring up SQL Plus, there's my user table, and while I'm here I'm just going to add a default value in there. So there's for my first record. So commit that. So just to summarize then, we created a couple of entity types, my user entity type, my logon history entity type. Those were transformed into the physical database definitions, the database, the table space for, in this case, Oracle. But if I was targeting multiple databases, I could choose a different database, and here I can see the same definitions for DB2 or for SQL Server, for JDBC, etc. So you can choose the type of database, and one of the advantages of CAGen is you can generate code for multiple platforms from the same model. So that concludes this module on data model and data structure, and then in a subsequent module we'll look at how we make use of that to create some code that's going to access the database.